Good day, my dear students. This Ss1 Mathematics, our topic today is algebraic fractions. Specific objectives: at the end of the lesson, the students should be able to simplify algebraic fractions, do some operations on algebraic fractions. What I mean by some operations is either addition, subtraction, multiplication, or division, or some other operations based on what you call BODMAS. You have to solve equations involving fractions. You have to do substitution of values in fractions and solve the problems resulting from them. You have to solve simultaneous equations involving fractions and then solve problems on undefined fractions. We start algebraic fractions. We say here algebraic fractions are algebraic expressions or equations in fraction form. This thing means in fraction form. We mean here algebraic fractions are algebraic expressions or equations in fraction form, not algebraic form. It is in fraction form. Look at it. It means that such algebraic fraction can be in expression form or equation form. A mathematical system is said to be an expression when there is no sign of equality, but immediately a sign of equality is assigned there, the system turns to be an equation if it is an algebraic system. Remember, an algebra contains at least a variable, some constants, and possibly a sign of equality if it is to be an equation. For example, here we say these are some of the examples of algebraic fractions. The first one is from New General Mathematics Ss1 exercise 4F number 1A. That's what I mean by all these things. This is an algebraic expression. It is a fraction, but it doesn't have a sign of equality. This one does not have a sign of equality. Any of them that doesn't have a sign of equality is called an expression. So numbers 1, 2, 3, and 4 are algebraic expressions. And immediately we go into number 5, you see a sign of equality, which means such algebraic fraction is an equation. Number 6 is also an equation. We carry on. Operations and simplification in algebraic fractions. By operations and simplification in algebraic fraction, we mean employing addition, subtraction, multiplication, division, and other mathematical operations to bring given algebraic fractions to their simplest forms. That grammar has to be explained better here by examples. He said, example, simplify the following algebraic expressions. The first one, which is lifted from the former examples given to you, is from New General Mathematics Ss1 exercise 4F number 1A. You have to simplify the first one, second one, third one, and fourth one, and possibly as many as you can. Solution: in order to do this, we consider the denominators of the individual fractions contained in the system and we take the LCM. You know how to find the LCM of numbers or variables. The LCM of 9 and 9 is actually 9, and you do it as you used to do it before. 9 dividing 9 is 1, multiplying 4x is 4x. 9 dividing 9 is 1, multiplying x is x, and 4x plus x simply means 4x plus 1x. So please note this. So we will give us 5x, and what we have here is now 5x over 9, which is now in its simplest form, since there is no common factor between the numerator and the denominator. So it can no longer be further simplified. As a result, where we are now is actually the answer. The next one is said simplify 3 over 2ab plus, okay, this one we have to simplify this, 3 over 2ab plus 4 over 3bc. What is the LCM of 2ab and 3bc? Actually, the LCM of 2 and 3 is 6. AB, BC, B is in both of them, so B has to appear once, A has to appear there, and C has to appear there. So the LCM of AB and BC is simply ABC. We go into the division. 2AB dividing 6ABC, 2 will divide 6, please keep quiet. 2 will divide 6 to get 3, multiplying 3 is 9. But AB dividing ABC, we cancel A and B, leaving C behind, which will multiply 9 again to get 9C. Again, 3 dividing 6 is 2, multiplying 4 is 8. And BC dividing ABC, we cancel B and C, leaving behind A, giving us 8A here. Since this is 9C and this is 8A, you cannot add 9C and 8A because it is as good as adding 9 oranges and 7 and 8 mangoes. You cannot get a single fruit there. What we'll get is actually 9 oranges and still 8 mangoes. Meaning therefore that the result is 9C plus 8A all over 6ABC. Here, it is not even well done here because, okay, it is well done. I thought 2 could divide, but since 9 is here, which is not divisible by 2, we leave it the way it is here. And we are done simplifying this. The next one, we take the LCM of 5 and 6 in the third one. LCM of 5 and 6 is 30. 5 dividing 30 is 6, multiplying 2 is 12. This 12 has to multiply this whole bracket, and 6 dividing 30 is 5, which has to multiply 5x plus 5 to get this. Opening brackets, 12 multiplying 3x is 36x, and 12 has to multiply minus 2 to get minus 24. Go to 5 and do the same thing. 5 multiplying x is 5x, and 5 multiplying 5 is 25. Okay. What do we have here? This is 30, and it is written 6. Who wrote this thing 6? Change it and put it 6. Put it 30. This place is 30. I don't know what is going on there. Okay. Please, my dear students, write this thing 30. Write it 30. Write it 30. Write this 30. Then, collect like terms at the numerator. We get 36x plus 5x, put them together here. And then, collect 25, put there, minus 24, you get this. This thing, still change it to 30, please. This is 30 because the LCM of 5 and 6 is 30. So, this thing is not 6, it is 30. This is not 6, it is 30. Then, 36 minus 5, plus 5. 36 plus 5, what is it? Carry 4 from here, put here, it becomes 40, remaining 1. So, 36 plus 5 is giving you 41. So, we get 41x. 25 minus 24 is 1. Remember, this is 30. So, our answer is actually 41x plus 1 all over 30. Write this thing 30. As you are copying the notes, you change this to 30, please. Don't say I did not tell you. Over to number 4. Number 4 is simplify 9x squared minus 49 all over 3x plus 7. We simply rewrite this. We know that 9 is equal to 3 squared and 49 is 7 squared. Now, what we have here, instead of 9x squared, we shall have 3 squared x squared. Then, upon factorizing 3 squared x squared, we get 3x all squared. Then minus 7 squared, maintaining the denominator at 3x plus 7. Looking at the numerator, this now is looked at as a difference of 2 squared, and remember how to factorize a difference of 2 squares. Just prepare 2 brackets, put plus in one, put minus in one. Each of the squared quantities has to go into the bracket once. Having seen this, the content of the denominator is also found at the numerator. So they can cancel out, leaving us with 3x minus 7. So our final answer becomes 3x minus 7. We move on. Remember, put down everything in your notes. Next, equations involving fractions. He said, we shall be doing here, okay, what we shall be doing here is solving equations given in fractions. For example, we are to solve the following equations. The equations are obtained from your New General Mathematics. The first one is New General Mathematics SS2, exercise 17E number 3. The second one is your New General Mathematics SS2, exercise 17E number 14. And the third one is still your New General Mathematics SS2, exercise 17E number 23. We are to solve the equations. These ones are equations because there are signs of equality. We carry on. Solution, the first one, we are given this. E here has to be written as E over 1. And we look at the left-hand side of the equation. Take the LCM of the denominators. The LCM of 3 and E is 3E. We do our work. 3 dividing 3E is E, multiplying 7 is 7E. And E dividing 3E will give us what? 3, multiplying 2 is 6. So we are left with 7E plus 6 all over 3E being equal to E over 1. By what you call cross multiplication, E will multiply 3E to get this, and 1 will multiply 7E plus 6 to get this. Upon opening brackets, we shall get 3E squared to be equal to 7E plus 6, and collecting all terms to the left-hand side will give us a resulting quadratic equation which can be solved in order to get the values of E. We shall use factorization method here, knowing that minus 7E is equal to minus 9E plus 2E, so that we can factorize in pairs. The common thing between 3E squared and 9E is 3E. When 3E divides this, we are left with E, but when 3E divides 9E, we are left with 3. Here, 2E minus 6 has 2 as a common factor, which when we divide 2E by 2, we get E, and dividing 6 by 2, we get 3. So everything now is equal to 0. Since E minus 3 is common to both of the factors, we shall pick one of them as E minus 3, and the quantities outside the brackets are to be put in a single bracket to get 3E plus 2. Now, if the product of two quantities is equal to 0, either of the two must be equal to 0. That's why we say the first one is equal to 0 or the second one is equal to 0. Then solving for E, we shall get going down that E is minus 2 over 3 or E is equal to 3. Can we continue? Yes, you said yes, so we continue. Number 2, 3 all over C minus 2 is equal to 3 all over 2C minus 5. Do the same thing we did before. You do your cross multiplication and collect terms. 3 multiplying 2C minus 5 and 3 multiplying C minus 2. To get this, open up brackets. 3 multiplying 2C is 6C, but this 3 has to multiply minus 5 to get minus 15. Do the same here. 3 multiplying C is 3C, and 3 multiplying minus 2 is minus 6. Then collect all like terms. To get your 3C to be equal to 9, so C becomes 9 divided by 3, which is exactly equal to 3. We carry on. The next one. This looks like something difficult, but it is not. What do? We check the contents of the denominators of each of the fractions. Looking at each of them, this is not equal to this and this don't have anything in common. This and this don't have anything in common. We then go back to what we call the factors and the LCM, HCF of a given set of numbers, we say that two numbers are said to be relatively prime when their HCF is equal to 1. And once such a thing happens, their LCM becomes their direct product. So as a result, since there is nothing that can divide this and this or that commonly, the LCM becomes the product of the three quantities. That's why I have them here at the LCM. Remember, whichever one that is going to divide this will delete itself from the denominator, and the dividend is going to be the remaining quantity when that particular divisor is removed from here. That's why we have the dividend as 2n plus 1 into n minus 1, leaving behind 2n minus 3, which has to multiply the numerator in order to give us the result. Do the same thing all through. When 2n plus 1 goes into dividing, it will delete itself, leaving behind 2n minus 3 and n minus 1. That's also what n minus 1 is going to do. And remember, 0 simply means 0 over 1. Here, when, after opening all these brackets, the first bracket got opened, the second bracket got opened, then the last one, I still put them in bracket because of this negative sign, because negative sign always affects a system like this when we are not careful. So it means therefore that we have to be very careful whenever we are doing this type of thing. And having done it in this way, we can now open this bracket again, for which this negative sign will affect the signs of the individual contents of this particular bracket. To get it like this. So instead of plus 4, we have minus 4. Instead of plus 2, we have minus 2. Instead of minus 6, we have plus 6, because minus multiply minus is plus. Minus multiply minus is plus. But minus multiplying plus is minus. Again, having gotten everything in this way, according to the powers, we are going to arrange them. The quantities containing n raised to power 2 have to be assembled one side in that order. So we go on. Having assembled them, after ordinary simplification, we get here 2n squared plus 2n squared will give us 4n squared. Then we have minus 4n squared minus n minus 5n plus 4n will give us this, because minus n minus 5n will give us minus 6n. Then 3 plus 3 is 6. We simplify our work here. 4n squared minus 4n squared will travel, because the result will be equal to 0. Minus 6n plus 4n, you are owing 6 naira, you are having 4 naira. When you pay, you are still owing 2 naira. That's minus 2n. Then minus 1 plus 6 means you are owing 1 naira, you are having 6 naira. When you pay, what do you have? 5 naira. The numerator now becomes over the denominator. But when you do your cross multiplication, 0 will multiply this and 1 will multiply this. So your job is done. After multiplication, 0 multiplying as many numbers as possible, even if there are billions of numbers there, will simply be equal to 0. The product of 0 and any number is equal to 0, including 0 itself. So we open this bracket to get minus 2n to be equal, okay, plus 5 equal to 0. Upon solving, we get our n to be equal to 2 and a half. Okay. Substitution in fractions. In some cases, certain values may be assigned to the variables contained in the algebraic fractions and will be needed to evaluate the system by substitution of those values. Let's go on. Is it, for example, your new general mathematics SS1 exercise 4J number 13 and number 17. It states, I read, if A is equal to 1 and B is equal to 2, C equal to 3, M equal to 4, and N equal to 5, find the value of each of the following: BCN all over B plus C, Next, c squared plus m all over n squared plus a. So we carry on. We write the first one, bcn we mean 2 multiplying 3 multiplying 4 all over b plus c means 2 plus 3. So 2 multiplying 3 is 6, multiplying 5 is 30, and 2 plus 3 is 5. So 30 divided by 5 is 6. That's the result. We carry on. Next, c squared plus m will be 3 squared plus 4, and m squared plus a will mean 5 squared plus 1. So 3 squared becomes 9, then plus 4, which is 13. 5 squared is 25, plus 1 is 26. So 13 over 26, 13 can divide up and down, the numerator and the denominator, to give us 1 over 2, which gives us the result. Next example. We say here, given that m is equal to 2x minus 1 and n is equal to 1 minus 2x. The irony of this is that m is minus n, if you think very well. However, just follow us. We are to evaluate minus 2n squared all over 5m, leaving your answer in terms of x. We go on. Solution. We are given minus 2n squared all over 5m. We write minus 2. What's the value of n? N is 1 minus 2x. We square it. What's m? M is 2x minus 1. So we multiply out. Squaring this one first will give us this, multiplying this. Because the square of a quantity means the product of that quantity and itself. We go on. I introduced a negative sign here because instead of writing 2x minus 1, I've decided to write 1 minus 2x, which means I turned it. In order to turn it like that, you have to introduce a negative sign, which is this one. As a result, the denominator looks like one of the numerators, which can cancel out, leaving behind a single 1 minus 2x. Okay. Here we have minus 2, here we have minus 5, but minus 1 dividing each of them will leave us with 2 over 5, which has to multiply the numerator, which has to multiply 1 minus 2x. You understand what we did? The game that played here is, I turned 2x minus 1 into 1 minus 2x, then introducing negative sign, so that if I return it, it can still turn the system again. Okay, it is possible to see some simultaneous equations in the form of fractions. Here we have simultaneous equations involving fractions. It says you may have known how to solve simultaneous equations. I know you know about elimination method, substitution method, graph method, even use of matrices to solve such things. So it is important that you understand that such a set of equations can be solved, can also be given in fraction. If they are given in fraction, what do we do? Example, solve for x and y if 3 over x plus 8 over y is equal to 1 and 6 over x minus 12 over y is equal to 5. What do we do? We state what we are given by solution. This is what we are given. We are given this and that. What do? We rewrite the system in this form. Instead of 3 over x, we say 3 multiplying 1 over x, which is also 3 over x. Instead of 8 over y, we say 8 multiplying 1 over y. We do the same thing here, which reads 6 multiplying 1 over x and 12 multiplying 1 over y. The same thing, this one also means the original thing given, so that we can simplify our work. We go on. We choose to say, let 1 over x be represented by m and 1 over y be represented by n, so that we can have something that we can easily handle. We now have 3m plus 8n to be minus 1 and 6m minus 12n to be 5. Then we rewrite them, setting equations 1 and 2. This now looks exactly like what we have been solving. So, but we want to employ elimination method here. making sure that the coefficient of a given variable become equal in each of the equations. So the coefficient of m here is 6, and we will want to make the coefficient of m in the equation 1 to be equal to 6. The only thing we can do is to multiply equation 1 by 2 to get a third equation, which still remains the original equation 1. Having done that, we have to see that the third equation, which still means the first equation, equation 1, we read 6m plus 16m to be equal to minus 2, while equation 2 is not affected. Next, we subtract equation 2 from equation 3 to mean 6m minus 6m is equal to 0, and 16n minus 12n will give us 28n. Y minus 2 minus 5 will give us minus 7. So we divide both sides by 28 to get minus 1 over 4. So n is equal to minus 1 over 4. Remember, you are looking for x and y, not n. So keep n equal to minus 1 over 4 intact until you get ready to use it. Second step, where are you going? You say using equation 1 says 3m plus 8n is equal to minus 1, but we have already gotten m to be equal to minus 1 over 4. So we put it here. 8 multiplying minus 1 over 4 will simply give us 2, because 4 will divide 8 to get 2. Multiplying minus 1 is equal to minus 2. So we shall have 3m minus 2 to be equal to minus 1. Now, evaluating by adding 2 to both sides, we shall get 3m to be equal to 1. Therefore, m becomes 1 divided by 3. We are solving for x and y, and we have gotten the values of m and n. Then we go ahead to check what is happening. Or we say, remember that 1 over x means m, and 1 over y means n. So it then implies that 1 over x is equal to that 1 over 3 we got. Instead of writing m equal to 1 over 3, we simply write 1 over x is equal to 1 over 3. And therefore, 1 over y is equal to minus 1 over 4. Here, do your cross multiplication. 1 multiplying x is x, and 1 multiplying 3 is 3, meaning that x is equal to 3. Here, minus 1 multiplying y is minus y, and 1 multiplying 4 is 4. So we divide through by minus 1 to get y equal to minus 4. In general, x is equal to 3, and y is equal to minus 4. These are the values of x and y. Next, undefined value of fractions. They should read undefined values of fractions. So we say an algebraic fraction is said to be undefined if and only if, this thing is not wrong, IFF means if and only if, it is equal to 1 over 0. We say in general, a number or a quantity is said to be undefined if and only if it is equal to n over 0, where n is a member of the set of real numbers. So it means that any number can be at the numerator, but the original thing is the nature of the denominator. A system is said to be undefined if the denominator of the resulting fraction is equal to 0. So we'll go ahead. Solving undefined problems. How do we solve such problems? We say problems, find the values of s for which the following expressions are undefined. What do we mean? Source of information, New General Mathematics SS2, exercise 17F, number 5. And the same New General Mathematics SS2, exercise 17G, number 16. Go there and check. We want to solve this and that. Solution, we write, just equate the system given to you to 1 over 0 and use your cross multiplication to help yourself. When 1 multiplies this, we shall get 2x minus 5, and when 0 multiplies 6x, we get 0. Solving will leave us with x equal to 5 over 2, which is actually equal to 2 and a half. Remember, whatever you see, you write it down. Be very careful. Any error that you observe, try as much as you can, based on my explanation, to put it in order. Next one. 2x plus 11 all over x squared plus x minus 20 is the next expression. Equate it to 1 over 0 and do a cross multiplication again. This one has resulted into what we call quadratic equation, which can be solved by any method that you know. Here we are employing factorization, upon which we landed at x plus 5 into x minus 4 being equal to 0. And remember that when the product of two quantities is equal to 0, either of the two quantities can be 0. At least one of them must be 0. We carry on. It means that x plus 5 is 0 or x minus 4 is 0. By solving, we get x to be equal to minus 5 or x to be equal to 4. We move on. Assignment. First assignment says solve the equation. This is the equation given to you. Check your textbook. It is in New General Mathematics SS2, exercise 17G number 12. Second question, you have to simplify this particular algebraic expression. You can see there's no sign of equality there. You have to simplify it. Source of information, New General Mathematics SS2, exercise 17G number 18A. Okay. When you are done, you submit to your Google Classroom. Thank you so much, my dear students. Stay at home and stay safe. God bless you.